Hello students, Mr. Greg here, and I wanted to welcome you to lesson number 5 of our Electronics 201 class. As you can see, we're going to build on last week's lesson, and basically what I'm going to do is show you how to hook the fan up and how to program the Arduino to come on. Actually, to tell the fan to come on when it reaches a certain temperature. And so maybe I can make this fan turn on here. You can see it's currently 81.14 degrees, and I don't know if I can make this thing go up or not, temperature to kick on or not. Looks like it's rising a little bit here. Let's see. Look at there. Gets 82 degrees, the fan kicks on, keeping me nice and cool. And so we've got a lot to hook up today. I'm going to pause it, unhook everything, and then show you how to hook the fan up at the power supply. Sort of a review from lesson number 10 in Electronics 101. And so you may have forgotten how to do that, and I'm going to help you out. So I'll be back in 1 second. Okay, I've unhooked the wires, believe it or not, and I'm just going to go over how to do this. So I need you to get out your power supply module along with the cable with the barrel jack in it. Looks like this. And you're also going to need your 9-volt battery. Now, the one that came with the kit is dead. So I have gotten another one. And then I need you to get your motor out with your fan, like this. And then I need you to get your L293D integrated circuit. Remember, this is the motor driver. And it has, in real small print, it'll say L293D will be etched on there. All right, so I told you to leave your everything hooked up, and I hope you did. But still, with that, I needed to make some modifications so to make room for all of this to fit on the breadboard. So the first thing I did was move the sensor, the temperature and humidity sensor, all the way to the edge here, and I'm going to need you to do that and hook it up. Remember that the the ground is to the far right, the voltage is in the middle, and then the readout pin. And then I've changed my readout pin to pin number 4. And so you need to plug that in to pin number 4. Now you need to make sure this is all turned off. If not, turn it off now. Definitely unplug your Arduino when you're hooking up wires. Another thing I need you to do is take off the 5-volt connection. Remember, we were powering everything off from the 5 volts from the Arduino, and the motor draws too much current or amps for that, and that's why we are going to use the power supply to run everything. So I think I have covered what you need. The first thing we're going to do is plug in our power supply, and you'll notice that the power supply has a positive and negative indicators, pins, and you have 2 sets here. And so I've moved my LCD over, and you just need to plug it in right here on the end like that, so it fits nicely. So my LCD is still hooked up from the last lesson. So what I'm going to do now is I'm going to go ahead and show you the wiring diagram. And what I've done is I have left off the wires for the LCD because you should have those already hooked up, and I have just included the wires for the motor and the humidity and the IC. And so you can see that, you can pause, and that's kind of what we're going to do if you want to print it out just to follow along. And these are the wires that we're going to add to that. And so I'm going to switch back and I'm going to go over that with you. Right now, I'm going to unplug my mouse. So I'm going to be needing that slot here pretty soon. All right, so our IC, if you were here for lesson 10, is pretty straightforward to hook up. Definitely you need to put it here where it's across this ridge so that one side is on that side of the ridge and one side is on this side of the ridge. And you'll notice the IC has a little notch in it right here on one side. I hope you can see that. Maybe I can zoom in a little bit here because I know I got a few students. You can see that notch now. All right, so that notch tells you that that means pin number 1 starts here. 2, 3, 4, and that's how we know how to hook it up. So when you put it on your breadboard, you need to make sure that notch is to the left, and that way you'll be hooking it up correctly. All right, so first thing we're going to do to hook this up is straighten my board a little bit. And just looking at the diagram, the pin all the way to the right here, the far right pin, is actually a power pin. And so I'm going to hook that to my power rail, which we've already established in the previous lessons. And so I'm using these breadboard connectors here to help you see a little better. Then the second pin actually goes to pin number 5 on the Arduino, and I have this drawn in yellow, and so I used a yellow wire just to try to help you out, try to keep it from being too confusing. All right, and then the next pin actually goes to the ground on the motor. Now the ground on the motor is the black wire, and so I'm going to hook that into pin number 3, just like that. So the 4th pin from the right is not used, and so I will keep that one blank. The 5th pin from the right is the ground for the IC, and so I'm going to hook that up to my ground rail. I'm about to mess up here. To my ground rail, just like that. And take your time and count. 1, 2, 3, 4, 5. Hooked to the ground rail. The 6th pin from the right actually hooks to the red cord on your motor. So I'm going to hook it right here. Try to keep the fan from getting it. Like that. And then the 7th and 8th pins go to our Arduino. And so I have this one drawn in blue, and it goes to pin 6. And this one drawn in red, and it goes to pin 7. So it's really not too bad, actually. I believe that's all our new connections for this. So the next thing we need to do is get to coding. And so I'm going to start where we left off last week. And this is the code from last week. So rather than go back through everything that we did last week, I'm just going to start from here and write the new code out for what we need to do. And so I'm going to go over that with you right now. If you need to pause the video and make sure all your connections are hooked up correctly, then do so now. All right, so the first thing I think we should do is make some changes. We, if you recall, changed our sensor pin to 4, so I'm going to change it to 4 here, so I don't hopefully make so many errors like I did last week, but that's, again, I think valuable for you. Let's see, all that looks pretty good. I'm going to come down here and I'm going to put, you know, we need to give it a speed, and so it's got a speed pin. We need to hook that up, and if you remember, we've hooked, that's on the IC, and we hooked that to pin 7. So that's the speed pin, and we've got to tell our Arduino that we've hooked it to pin number 7. Let me just make sure you understand this. So we've got 3 output pins coming from the IC, right? And pin, this one, the one all the way to the left on the IC, is the speed pin, and we hook that to pin number 7. And so I've just told our Arduino that we've done that. And then, so then we've got 2 direction pins, right? And if you remember, we've got to declare them. Direction 1, we hook to pin 6, and this direction 2 to pin 5. And then we've got to tell it a speed. And so we're going to create a bucket for that. And we just call it M motor speed, right? M speed. And the motors runs off of digital, and digital is 0 to 255, right? And so we're going to tell it to go full speed because we're radical here. All right, liquid crystal looks good. All right, so then we're going to come down here in our code, create some space after that delay. So we crank the LCD up, we turn on the humidity sensor, and now we've got to set up the pins for the motors. And you remember how we did that with pin mode. So we've got the speed pin, and that is an output. Right? And then we've got our 2 direction pins. So we had direction 1, which is also an output. And pin mode, didn't turn the nice color. Direction 2 is also an output. So if some of this is confusing, you can go back on the YouTube and look at lesson number 10 in the Electronics 101, and it explains a little bit more detail how to hook the motor up and actually how to hook it up to a joystick if you're interested in learning how to do that. All right, so that looks pretty good. Now we're reading our sensor, right? Humidity, temperature in C, temperature in F. So now we want to set up a program to tell Arduino when to turn the motor on. Now, we could use an if statement, but really an if statement wouldn't work as well for this. And so it gives me a chance to teach you a new command, and it's called a while statement. And it works a little bit better for something like this. And so we will type in while temperature. So what do we want to do? We want it to turn on, right? And I'm just going to focus on Fahrenheit. So while the temperature is greater than a value, let's just say 80. Then we're going to put our open curly bracket here, just like we did in the if-then statement. Then what do we want to do? Well, we want to, if the temperature is greater than 80, then we want to turn the motor on, in this case. So we're going to do a digital write direction 1 is not on, and digital write direction 2 is on. So this turns the motor in one direction. Now, depending on how you hooked your motor up, you may need to do direction 1 high and direction 2 low so that the fan is actually blowing air out away from the motor. And you'll just have to experiment with that. But if you're not feeling air coming from the motor when it turns on, then you need to change these two parameters, low and high. All right, so now we're saying if the temperature gets greater than 80, turn the fan on. That sounds pretty good. But at what speed? Well, we've determined that speed, and so we need to do an analog write. And I spelled analog wrong. I knew I had an error because it didn't turn colors. So analog write our speed 10 to M, little m, capital S, speed. So we determine the direction, low and high, and then we've determined the speed, and we can change that speed up in our variables at the top. And then I'm just going to put a little delay in here. No, I'm not. Yeah, I am. Delay dt. There you go. I'm going to put this delay outside my bracket. All right, so if while it's greater than 80, then it turns the fan on, delay to settle, and then I still want to read what the temperature is. So I've done that. And if so, that turns it on. Well, what happens if the temperature is below 80? Then we don't want the fan on. And so we don't need, this is why the while statement is so much better. Remember, before we had to use if, then statements, and we would have to tell it to turn it off if it was greater or less than 80 degrees. So we're just saying while temperature is greater than 80, run. And if the temperature is less than 80, then the default is that the motor needs to be off. So we do digital write both of them low, right? So we've turned both directions off, and that turns it off. I want to make sure that everything looks good. I'm going to plug it in here. Let's see if I made an error, which you probably already know. I'm just going to download it, upload it. Uh-oh. Uh-oh. Unbelievable. Now, you've probably noticed that my LCD wasn't working very well, and we weren't getting a reading. So I want you to think about why that was. I want you to pause it and think about, look at the code, and tell me why my LCD is not lighting up at this point. So pause it, take a look at it, think about it, and come back. All right, now that you've come back, I want us to take a look at the sketch again. And let me get that back on here. So if we look at our while loop here, actually I had to change the temperature a little bit to make it come on. But if you look at our while loop, the Arduino is doing just what we told it to do, right? While the temperature is greater than 79 degrees, then turn the motor on at this speed. And it just continually goes through this while loop until this condition is not met. And then once this condition is not met, then it will drop out of the while loop, and it'll do slight delay. It'll digital write to the motor low, and basically stop the motor and display the temperature. Well, the thing that we didn't do correctly is that we didn't put this information inside the while loop so that we can see our temperature while it's in the while loop. And so I'm going to highlight it. I'm going to do a Control-C to get that. And then I'm going to come up here and I'm just going to paste my code in here like this. And that doesn't look very well. So I'm going to give me some space here. So now I'll still get the display whether I'm in the while loop or not in the while loop. And I'm going to keep from flickering. So I'm going to put this delay. I'm going to move it. Can I just drag that up here like this? Yes. Up here now, let's download our code. Go to our view. See what we get here. Oops, wrong view. Go to our view here. And I want that to be the camera view. All right, now the fan is running and we're getting the temperature and humidity while the fan is running. That's exactly what we wanted it to do. And then Let's change this to a higher temperature and download it. Which I'm just changing it in my while loop to 81. Oh, I went the wrong way. Yeah, that's right, to 81. So now my temperature is below 81, is not greater than 81. So my fan shuts off and I'm still reading my temperature. And so I probably could hold this sensor and I might be able to get the temperature up. Let's see if we can here. Slight delay. It's going up. See how hot I am today. Look at there. Bam! How cool is that? We've just created an automatic fan blowing nice cool air. Completely automated. So this is your homework. I need you to put the circuit together, get all your code, highlight it, Control C, either put it in an email or on a Word document and send it to me, and it will be graded and returned accordingly. So I appreciate your time. If you have any questions, as usual, give me a call.